So, hello, good afternoon. Maybe some people will come in later, but that's fine. So, welcome to our special event that we have called Generation Fusion. It's kind of the sequel of last year's Vision for Fusion, where we try to look at the long-term future, or longer-term future, because fusion definitely is something of the longer term. So last year we tried to look at scientific, technological challenges, also how to bring together private and public institutions. And this year we are looking at something that was not there last year, I think, but a very important aspect is the human factor. So we want to look at the generation that is hopefully going to bring fusion to the reality. And we want to look at their perspectives, their expectations, maybe their challenges or the difficulties they already encountered, and try to see how we can improve the situation and how we can make fusion really a reality. We have the same format as last year, a discussion that we will start internally here with the panelists, but then we want to open it to the audience, so you're all invited to bring questions forward. And hopefully this discussion session is going to end nicely, but I'm sure it's in the very capable hands of our moderator. This year it's Alf Kuhn-Zeeman from Stuttgart University, and he's going to bring a lively discussion to us, and I'm looking forward to it. So.
Thank you very much, Crystal. So indeed, my name is Alf Kuhn-Zeeman, as Crystal said. I work at the University of Stuttgart as a principal investigator. Besides that, I'm also on the board of governors of FuseNet. If you don't know what FuseNet is, we take care that everybody in Europe has access to fusion education. But that's enough about me. I'm your moderator today. You see on your right-hand side the agenda. So my task is to kind of guide you through the evening and trying to raise some questions, get a discussion flowing maybe, and yeah. So how this will work is as follows. We will first start with a discussion. Meanwhile, you can already think of questions. If you have already some questions and you have the problem that you might forget them, what happens to me always, you can use that link. It just brings you to a Q&A page. This is a Mentimeter thing. You can type in your questions, and then at the end we will see that question, or I will see that question. Don't worry, I will bring up the link multiple times again. It will be all online, the whole session. But if you don't like these electronic devices, we can also make like a classical raising the hand thing at the very end. So the panel discussion will take approximately an hour, maybe a bit shorter, maybe a bit longer. We will have a Q&A session of roughly in half an hour, because after I think then you might be tired. And we are coming then to the end when we will conclude. When we will conclude the event, Crystal will say a few words then. And after that, we have some drinks and some foods provided by our sponsors. We have two sponsors this evening. One is Renaissance Fusion. Renaissance Fusion is a European fusion company aiming to develop a commercial fusion power plant in the accelerator design, where Renaissance Fusion is focusing on three major techniques, adapting like simple piecewise cylindrical magnets to complex accelerator geometries, developing a liquid metal first wall for tritium breeding, and third, using like tapes for high temperature superconductors. And we have Celine Hu here. Thank you, Celine. If you have any questions for her, ask her. Thanks for the drinks already. And then secondly, we have Hayden Analytical. Probably most of you know Hayden. Hayden is famous, at least in our lab, for the mass spectrometers. Apart from that, they also have like, you can detect like plasma ions as well, neutrals, of course, radicals. For atmospheric plasma, data acquisition systems, Langmuir probes, all these type of things. We have Mike Thomas here. I'm not sure. He's over there, so if you have any questions. Also, thanks for the drinks, Mike. And then, very important note, this event is live streamed and recorded. It is live streamed on YouTube, also recorded on YouTube, so you can look it up later on if you want. Good. So let's get this started. Before we start with the panel discussion, I have a bit of a warm-up thing. So another Mentimeter. This is another one. If you were to scan this, don't worry, I'm not like annoying you. I have four very short questions. If you go to that website, you can either type it in using menti.com, then 65051670 as is written there, using your QR code reader to scan that. And then I have like 4 questions. This is just to warm up. I don't want to annoy you with all these type of things. This is just a warm up. What you think will be the very likely solution for a stellarator? Sorry, for producing electricity first. I just realized, and sorry, this was not intentionally, that I'm using a torus diagram here. This was indeed by accident. I'm sorry about this, yeah? Unintentionally, completely. If anybody is clicking Cold Fusion, come to me afterwards. I'm happy to have a discussion with you. And yeah, I mean, don't worry, this was not bad in a bad way. I'm just like in a lecturing way. Yeah? Okay, interesting. Yeah, that was maybe a bit right. Okay, I see. Okay, so we have the tokamak, well, majority, let's say. We have some stellarators, inertial confinement as well. As you know, MCF is probably a bit larger than ICF in terms of people, and we will discuss that later on. So this is just to get an idea of kind of what people are thinking. Then I have 3 more very quick questions I want to ask you. Very simple ones. So since you all have Mentimeters, then come to me, the Code Fusion guy, afterwards. I'm happy for a discussion. Don't worry, it will be privately. You don't need to do it publicly. So one thing, since this is about the human factor in the field, and this is about your worries, your kind of problems which you have, I'm wondering, have you ever in your whole career considered leaving the field? I definitely have, so I would raise my hand, yes, I have, for different reasons. And I'm, oh no, never, okay, that's interesting. A lot of people, maybe the young people, haven't encountered the challenges like I have, like non-permanent positions, for example, limited contracts, going abroad, going not abroad. Okay. So we have quite some people having considered leaving the field. The directly follow-up question to this, triggering the discussion, is not if you have considered leaving the field, but, oops, not working. What would you prefer in an ideal world? Would you stay in the field or would you leave the field? Like, just out of curiosity, if the people are mostly happy with that. Okay. Okay, that's quite a clear thing. People, yeah, not decided yet. That's fair enough. Doing your PhD or doing your first postdoc, of course, kind of to get an orientation of how life is going. Okay, that was very, very quick. We already have like 64 answers here. Good. And don't worry, this is not the very last one. And then we start with the discussion. What is, in your opinion, the biggest bottleneck in fusion? Is it physical challenges, engineering challenges? Is it funding? Is it to get sufficient young talent, like human resources, or is it public trust? That's kind of something I would like. Yeah, funding. What a surprise there. Yeah, sufficient young talents. I think that is a problem as well. Indeed, engineering challenges, I agree. Yeah, public trust, not many people clicking that. I think also my experience, but I'm okay. Funding and engineering challenges. I think this is something, if I were to weight these problems, I probably might have done it in a similar way. Okay, good. Well, thank you for your input. I'm now switching back to the presentation. Thank you very much for that. Just as a kind of, what is nowadays called an icebreaker. These are the panelists, and in a moment I will move over to them. You see we have 6 panelists from different fields. Once again, the QR code brings you to the question session, to the question page. If you have any time, any questions, go to that page and type it in. So I just start from the left to the right, quickly reading the names. So we have Duncan. Duncan is a postdoc working at the Taranis project, kind of academia, private connection at the moment, I would say, combination, working in ICF. Then we have Hervé. Hervé works at a startup at the moment. He's the CTO of GenF, working in ICF as well, with a long experience in laser development. Then we have Antonio. Antonio also works at a startup at Gauss Fusion. Antonio works in MCF. He has an experience in stellarator turbulence and now is maybe building stellarators. Let's see. Then we have Marjana. Marjana is sitting in the middle. Marjana is a postdoc from the Vilnius University with a background in quantum optics. And we will have very thankful for her being here. We have Felicity then, being a PhD student, probably to finish this year, no pressure. University of York, in combination with Tokamak Energy and UKA, so an interesting private and public funding as well, working in MCF. And then we have Andrus. Andrus is a deputy director from the Lithuanian Energy Institute with a background in plasma technology. And now I will quickly move over. Perfect. Okay. So thank you. You already got kind of your big hands for coming here. We really appreciate that. And we thought about a few questions. And then in the beginning, I want to start with you, Felicity, as a first question. What motivated you to enter the field of fusion, and did your expectations so far matched reality?
Does this work? Yes. So I think I first heard of fusion at school when we were learning about it, and what I remember of the physics lesson was that we were learning about fission and fusion, and my physics teacher said, fusion is the ideal energy source, but it's impossible. And I was like, oh, well, that's a shame, and sort of moved on. So then I went and I studied natural sciences, actually, for my undergraduate, so physics, chemistry, and maths. And the course was run by Roddy Van, who lots of us know. And that's basically how I then sort of fell into it quite, serendipitously. So Roddy just needed someone to do a summer project for him. I just knew it was about plasma. I didn't know what a plasma was. I knew it was on a computer. That's all I knew. And then it ended up that I was actually working for STEP, and that was then super cool. Basically, all I understood about it at the beginning was I was working on a fusion power plant, this thing my teacher said was impossible, and that this power plant was going to be built by 2040. So yeah, that was just mind-blowing. I was like, right, this is now what I'm going to do. So that's basically how I got into it, because then I was at York with the York Plasma Institute, so I did a master's project with Ben Dodson on diverters. Now I'm back to current drive, and that's sort of how it. But it's interesting how then I was like, you kind of come into it with very green eyes, yes, this is going to work by 2040, we will have a power plant. And now, throughout my PhD, you learn, on the CDT, we have lots of talk modules. I remember we went and did a module about materials science for fusion in Oxford. And by the end of that week, I was like, God, this thing is never going to work. The materials science is so hard. I think we all probably have days when we are more optimistic or less optimistic about the fusion timelines, but definitely I now know a few more of the challenges than when I started. So in that sense, probably, I've learned a bit more about it, but I'm still optimistic, hopefully.
Good to hear that. Yeah, an interesting kind of role model played an important role in that, like Roddy having a good teacher. Yeah,
definitely.
Yeah, thank you. Interesting perspective. Kind of following up on that, maybe from a slightly bit different perspective, Duncan, addressing you, your postdoc with some experience now. You did your PhD in 2021, correct? Yeah.
Yep.
So what do you see from your perspective as kind of the main obstacle for an early career researcher to stay in the field for a long term?
Yeah, it's a good question. So for me now, I finished my PhD in 2021. I did a short postdoc in the UK of about 6 months, and then since then I've done 1-2-year postdoc in Bordeaux, and I'm halfway through my third postdoc in Paris now. One of the major obstacles is more stable employment for early career professionals, I think. It puts a lot of people off, and it's also a self-selecting criteria. So it's really selecting towards those who are willing to move themselves, change their lifestyle, be adaptable, which can be beneficial, but it's also narrowing our field of selection for who's entering the field. So personally, I see that as one of the major obstacles. Yeah,
thank you. I think I agree with that. As a third question, addressing you, Marjana, you're not from the fusion field, but you are from quantum optics, and I think you have, with your career that you have some good insights into kind of what aspects of mentoring or, let's say, career guidance played an important role, if in your career so far, and how important do you consider that for you?
It was really important. I think if I look back and where now I am, yes, it made a huge difference. And thinking about your plasma community, if you're not based at a flagship institute or at a huge collaboration like ITER, chances that you will meet senior mentor outside your bubble are really negligible. They are really small. So many early career researchers, scientists, okay, what we can get an excellent technical support when we are working on some specific project, when we are developing some diagnostic tools or working on code. But however, there is really small little guidance on how to actually build their scientific career, how it goes afterwards. So we are not given that information. And I think there is a still lack about that, because we talk about a lot about training those people, young researchers, via those summer schools or specific programs when we can learn, but we barely train them like those critical skills, how to apply for funding, prepare their first proposals, building some network. So here we do it in a nice way, but how to manage team or transfer into the leader's position afterwards. So those all that I mentioned are soft skills, and I know that soft skills for physicists, it's not our strong point. It's not commonly associated as our strong point. So it's true, but it's learnable, I think, and in the long term, it pays off, I think. And for example, if we navigate for funding or explore non-academic career, because for example, today you will hear many fantastic pathways, but still I think that a lot of you think that it's all or nothing. It's either academia or just it, you leave it, and it is, yes. But fusion is so deeply collaborative field, yeah, so we should learn, and we need this conversation as early as possible. And we need not only mentors, but also role models here, just to shape our sense of belonging to community. I think it matters, because those informal mentorship cycles I had, European Physical Society has a nice section of young minds. Yeah? It gives a lot of opportunities, discussions, both networking, and you met there some mentors. So without pressure, you can talk about what awaits you. And because we have those talents, it's not like because we aren't capable, but because in time we do not feel that they belong. Yeah, so mentorship is really big deal. And a personal note, if you talk about Lithuania, and you mentioned quantum, but for everybody, when we mention Lithuania, we know that here children born know already how to play basketball and how to construct their first laser, because we are a country of lasers. So our photonic ecosystem is really strong one. It offers so many paths in academia and outside it. Therefore, our quantum community and our plasma community are really small ones. That's why visibility is vital here, yes. So once again, guidance really, it's here a big deal. So this visibility means that speak a lot, bring those people. It helped me sometime, so 1 year ago, to go and talk about it to government of Lithuania, with Minister of Defense, even with people from army. You just need to adjust your talk and say, it's important, not only lasers we have, but we have brilliant people. So that's how we signed previous year declaration on quantum technologies, that we want to build this quantum ecosystem in Europe, yes. And this year we prepare a national quantum strategy. So I think it's this now begins to form. So maybe more programs at the universities will form and launched, and it will help us to get those people with critical mass. And we can do the same thing with plasma and fusion here. So visibility, community matters. Nice example. And we had this question in the beginning in what we believe. And Wendelstein 7x, so from Max Planck, they on June showed nice results, demonstrated triple product. It's a really inspiring story, but I Googled it and I see how huge, heavily funded it is by German government, federal government. So they believe in fusion. They believe in it, and that's how this ecosystem, if you compare it 5 years ago, how it was, it's changed a lot, drastically. So scientists who are, so researchers, even in plasma community, yes, so who are willing to speak not only inside the lab, but outside it, to public or to policymakers, can make a change. And if, okay, Wendelstein 7x, it's scientific example, but we can talk about SpaceX, how people are always excited when every rocket is launched to the space. Nothing changed, but still we feel this excitement. So I think fusion offers constant novelty, and if we don't pay attention enough, it can seem boring, yes, but it's not. It happens a lot. Repulsion rockets, fusion, and so on. So we need to show that our human face and inspire young people to choose this path.
Yeah, thank you very much. I have a very interesting first point in particular, where you said soft skills are so important. This is a discussion we often have at our institute, how useful these are. So good to hear that from you. And I think, Duncan, you wanted to comment on that shortly?
Yeah, if it's possible. I really, the things you're talking about, mentoring and a mentor in the field is very important. And just referring back to the point that we were talking about as well as obstacles is, personally in my career, I've been very lucky. I feel like right through my supervisors have been very good and very, they've pushed science and they've also pushed my personal development. But I've seen colleagues alongside that one of the main reasons they're leaving the field or have lost trust or don't want to continue in science in general is because of lack of proper supervision. And so I don't know all the solutions, and I can see how a lot of the solutions that I could possibly offer might turn the structure more into a diploma mill. If you too strictly regulate how masters, PhD are done, it becomes just another stage of undergraduate. But it's another big question for me, and continuing, great minds in the field and a great diversity. I think importance is supervision and support. But yeah, thanks for the the great comments.
Yeah, thank you. Important point with the mentoring. Just one comment from my side also. Don't underestimate the effort of mentoring. There should be a proper human resource department in the back of it, also to ensure that it's not like getting into a bit of a toxic relationship, which I've seen as well. So mentoring is challenging, but rewarding as well. Yeah, interesting points. Andres, you have kind of a very good career in the research area as well in academia, and you're at a position where you're hiring people. So I'm wondering what do you think, in your opinion, are guiding values, or what would you say, which is important for the next generation of not necessarily fusion physicists, but physicists or researchers in general that you hire? Like, is it like innovation? Do they need to collaborate, scientific impact, whatever? What is your kind of opinion on that?
Thank you for the question. Yeah, since I represent the adjacent field of the plasma, low temperature plasma, but still probably we face the same issues and problems. Regarding the impact, probably at the early stage of the career, if we take the personal metrics of the researcher, his impact is relatively low. Let's say age factor, citation, and so on and so forth. But what I see, let's say, in the Eastern European part, that's from my personal experience, what distinguishes from the Western European part, that's mobility. Being at the early stage or being a student, in Western Europe, students are very mobile. They are eager and want to travel and to study, to get to know the other cultures. In the eastern part, probably it's more or less that we are sticked to the place we live, and let's say you can stay at one institution, or let's say research institute or university, the whole of your life. So probably this is the issue. From the other side, yes, regarding the family issues, the family perspective, you are settled down and this is okay, you can have the family and to live in one place. But from the other side, you are boiling in your own juice regarding the research ideas and how to make the things differently, but to have the same result in the end. So probably this is the issue. I mean, we do have possibilities to travel, but that's probably in our blood that we want to stick. Especially at my my generation or older, probably for the even younger ones, it's a less problem, but nevertheless, mobility one of the issues, and the other is networking. It's really important to have a long list of potential partners representing different institutions. I mean, industry, universities, research organizations, etc. Then you can collaborate more in terms of joint projects, joint research, and so on and so forth. So this is also extremely important to have a long list and diverse list. Yeah. So thanks.
Yeah, thank you for that. Partially controversial aspect with mobility, yes. It's requested, but then it's sometimes difficult to organize on a personal level, maybe. But just one comment on that, shamelessly advertising FuseNet again, sorry. We have mobility funds if you want to do, like being a PhD student, want to do an internship abroad for only a short time, a few weeks maybe. This might already help to get your network growing, which you said. So we have fundings for that. So if you're a FuseNet member or university is, you can get money for that. So sorry for that, just wanted to say it. Okay, yeah, let's continue with the discussion. Antonio, you kind of switched a bit from academia now to the startup, and so you studied at the EPFL, which is a very broadly oriented institute. So you probably have a very good background there and a good image into, or a good idea into a wide area of topics. And I'm saying that because so a colleague of mine, Andreas, actually sitting there, once said that fusion is kind of a multidisciplinary event. You could compare it with a pentathlon, maybe a heptathlon, or even a decathlon, I don't know. Meaning being a mixture of plasma physics, engineering, material science, computer science, you name it. So how, in your opinion, how well does the collaboration work between these kind of areas?
I think in general it works quite well. Let's say, I think there are two ways to look at. From the industrial point of view, it's not a question of if it works well or not. It has to. Otherwise, I mean, if industry wants to build something, it really needs to, all these people, they need to talk to each other so that the thing actually becomes true. But usually when I look at industry and universities, usually I imagine a river. There's the upstream where you have all the universities, all the knowledge being generated, and then downstream you have the industry. So if this collaboration is working well at industry, it means that at university levels it should also be working. And indeed, in my case, when I did my PhD at EPFL, at the Swiss Plasma Center, indeed I would see this collaboration going on. I mean, by time to time, I would see people from the materials coming to do a bachelor thesis, a master thesis, people from the math department trying to come up with some numerical method to solve some turbulence problem that we would have, people from the computer science. So I think this works well, but I can also very easily think of examples where it doesn't. for instance, yesterday I was having lunch with some colleagues from EPFL that are still doing the PhD there, and then one of them said, I don't know if data will say if this is true or not, but I guess it is. So let's assume that it's true. And he was saying, yeah, so in Switzerland there's 4 official languages, so but the 2 main ones is German and French. And he was saying, oh, the German-speaking people, they go to ETH, which is in Zurich, and the French-speaking people that wants to study engineer, they go to EPFL, which is in Lausanne, in the French-speaking part. And what happens is that the people that go study in ETH in Zurich, there's no Swiss Plasma Center there. So it means that all these great engineers that are going to be educated and formed at ETH, they will never be exposed to fusion. They will never heard about fusion because there's no experiment there, there's not an office there, so they won't know about it. I mean, probably some of them will know about it because they saw some YouTube video or they saw some LinkedIn publication, but they won't know that they are needed in the fusion, that we need them. We need mechanical engineers, and we're gonna need a lot of mechanical engineers if we want to build dozens of power plants in Europe. We're gonna need electrical engineers, materials engineers, and while at EPFL, even if you are doing life sciences, but you still know that fusion exists because it's the tokamak, it's this big building experimental that they have over there. So probably they end up doing some visit to the institute, and probably then there's an opportunity for a bachelor thesis there, even if they are not a plasma physicist, even if they are from a completely different field, but there's some opportunity to them. And just because they were exposed to it, they saw there was a poster where they used to eat, so they knew about it. Whereas people from a university, which is an amazing university, a great university, forming brilliant engineers, but just because they were not exposed to it very early, then these collaborations, I think they won't work out. So I guess this is also something for FuseNet to think about it. How can they reach universities and institutes where there's no fusion at all? Because this is probably the hardest.
Yeah, true. That's a good point. We are working on that. Yeah, I'm trying to reach
know.
school kids, for example, early on. But yeah, interesting. So I guess language can also be a barrier then, interpreting that what you said, like a French-speaking, German-speaking university.
It's true at the bachelor level probably, but these days at the master level, this is not an issue anymore. But of course, that then if people they do the bachelor at a place, then probably they don't feel so comfortable to move away. So this really needs to start a bit earlier, or just simply to have fusion everywhere possible. I mean, you don't have to have tokamaks or stellarators everywhere. We can have small things going on.
Yeah, it kind of goes into what Marjana said, so that we need more public information about fusion, kind of. So, Evie, I have a question for you. So you work at a startup at GenF. You're kind of new into the field, but you work at Thales before, so you have a bit of an experience there, I guess. So do you think that we have sufficient communication between public research and the privately funded fusion or not? And if not, do you have an idea how to overcome this problem?
Well, first, maybe as a first answer, yes, as you said, I'm not a fusion guy, even though I received my PhD well, in the 20th century, so by far the oldest on stage, on gas lasers. So that was my first exposure with plasma. I got to know more about fusion 2 years ago when we started out of Thales to create this Taranis project. And why I'm saying that is that obviously you would say, well, how can he be the CTO of a inertial confinement fusion, not being a fusion guy? And this is really thanks to, of course, a team of experts, but even more collaboration with national labs, specifically CEA and CNRS, people like Duncan and many people in the room, that we can do that we can really bring engineering perspective, but really with this very strong, fundamental pedestal of world-class scientists to be our CTOs and CSOs. So from this standpoint, the collaboration, public-private, is fundamental, and it has to be staged over the long term, because we all know fusion is going to take scientific work for a long time, and of course it will necessitate also engineering in parallel, but this collaboration will be necessary, and in our case it works really well, but I believe that we're not unique case. For this collaboration to work even better, I think, as probably Duncan mentioned, we have to build maybe more bridges to allow well, careers from academia to private and back. Maybe that's the back that is more difficult nowadays if you want to have an academic career. Moving to a startup or can be seen as kind of a deal breaker for an academic career, and that has to change in the mindset of mostly maybe the way some of those national research institutions are organized, and that from this standpoint would help a lot. Because on the positive side, what this collaboration brings and what the private initiative in Fusion brings, of course it brings funding, which is important, but it brings also long-term visibility so that young researcher or young students can really choose Fusion, not just because it's a very interesting field, a scientific field, but also because there is long-term roadmap both on the research standpoint and industry that really give them confidence they will refine their spot, find their the career they're wishing for with a high degree of confidence, and really excite their curiosity, which is to me the one fundamental skills or soft skills that we're looking for in engineers and scientists in Fusion, but even other fields.
Yeah, interesting point that you mentioned. Indeed, students always often ask me, like, what should I do, like, after my PhD, after my master? Should I leave academia and go to one of the Fusion startups? Maybe this is already the wording which implies that this is something which they think is indeed not possible to go back because it's something completely different, which they think. So yeah, I think an interesting point which you raised there. Going back maybe to a bit of a personal level as well, Marjana. So yeah, do you think, or do you have made any kind of experience in your career that there were like institutional, cultural barriers which limited collaboration between different disciplines?
Okay, so I'm returning back a little bit to Antonio's raised a nice sentence that we really need to talk with each other, and communication is a big deal. For example, here, even at national level, we have several institutions, and if you want to collaborate or work at several projects in different institutions, they are fighting over those scientists. It should not be like that. Yes, we should support that people are trying to do a lot. Yes, and going back once again to communication, because it's a barrier not between institutions too, but even between business companies, politicians too. I think in communication field, we had one great scientist who knew entire physics. It was Richard Feynman. And now, even when we are at the same floor doing different things, we don't truly understand what they proved previous week in their article or something like that. Yes, so communication is really important here, and many of barriers arise. I think that it will help, because I talked even with business people who are giving some money for our programs. They told me that they are missing this bridge between fundamental science and business, because what are applications? Their main question, that scientists always only focus on novelty, to do something that no one has done before. But it's in our nature, yes. That's why we call it science, and that's we call ourselves scientists, yes. And it's great, but how does it meet their needs? So irony is both, like once again, Antonio said that science and business can fall to the same trap. If they try to work independently, nothing works, because they truly need each other, even if their cultures are different. So, for example, we are working for several years chasing the same question and exploring the thing for months, and the result, sometimes it's not a good result, but still we can publish it and we can say, okay, this theory doesn't work. we should change the path. But in business approach, it's impossible. So, yes, it's impossible, but we cannot flourish in isolation. We need to communicate, and we need to learn how to communicate it for different public sections. Yes, so for public, for business, for politicians, because in today's society, isn't optional about communication going. It's a bridge. It's the only possibility. You can, I think a lot of you watched this movie, Don't Look Up. Yes. It captures the tension between science and society and what consequences can lead it when communication fails truly. Yes. So let's speak always. So I always tried to explain that fundamental science matters. What if no one had invested in Markov mathematical models in their time? It's the foundation that led to the ChatGPT and so. Yes, like for 200 years, people did not understand why Fourier transformation is a big deal, and now all entire IT sector is on that. Yes, and we have even a nice person from Lithuania, Virginijus Šikšnys. He worked a lot to improve yogurt shelf life, so to help defend it against viruses. No one thought at his time, okay, yogurts. Fundamental science, why we need it. But afterwards, yes, this discovery led to CRISPR-Cas. So gene editing, yes, now it saves millions of lives, and it should have been our first Nobel Prize. But on the list, no, 3 people get, and he was the 4th. So you never know. So my advice for everyone, fundamental science and fusion in plasma and quantum, everywhere it matters. So just speak a lot, communicate with each other, because great success does not come over one night. It comes after focused 15 years or 4 years of PhD or something, yeah. So, and as Duncan mentioned, yeah, always, or go back entirely, or try 50-50 in startup. Yeah, try. There are a lot of paths.
Yeah, communication is important. I agree. Talking about communication, you want to say something to that? Yeah.
Yeah, no, I was just going to add, because obviously I've been, because we've been talking about private to public and universities in terms of people. So, because I've been privileged enough to get to work throughout my PhD at all 3. So I've been at a university, a national lab, and a private company. And, what I've sort of noticed about it is that you have this sort of gradient, right, where the university is all about knowledge for the sake of, I mean, not all about, but a lot of being at a university, and the advantage of being at a university is that it's like knowledge for the sake of knowledge, and you have a lot of freedom to pursue as a researcher what you want to do, which has got great advantages. People also have disadvantages to that. And then at a national lab, it's much more focused, like everybody is working towards fusion, but you still have kind of some freedom within that generally as a worker as to what you do and what you think is important. And then kind of the other end of the scale, then you move towards a private company where the company is generally, moving towards very specific goals of, this is what our investors want, et cetera, And you might have, I mean, again, there's different advantages in that. Often you can be quite flexible in your role and what you're doing. And often you can be hands-on with the machine, that kind of thing. So all of them have advantages and disadvantages. And I think the real advantage for fusion as a whole is that different people fit into different categories. So I've come across some people who, do a PhD and then they're like, I really don't want to be in academia. And fusion might have lost those people, but now they've gone to work for a private company. So we actually have managed to retain those people who might have otherwise have left. Equally, some people aren't so much on the private side, but they really enjoy academia. So therefore, so everybody fits into, I think, a different slot of this, or might move around. And so it's a real strength of the fact that we now have this breadth in order to retain people, I think. And it's not necessarily a competition. It's not a competition between, national labs necessarily trying to keep people out of private, but the point is we all should be trying to get people in somewhere, right? Yeah.
Yes, a good statement. I like that.
Thank
Thank you for that. You talked about, like, I don't know, like communities fighting, public and private, but there's also ICF and MCF. So, Duncan, I know that you have some, let's say you had some motivation to join MCF as well. So what is, in your opinion, do you think there's a strong or good communication between ICF and MCF?
Yeah, it's a good point. So when I was originally applying to do a PhD, I was definitely interested in MCF. I was applying for those positions as well as ICF. I mean, I ended up in ICF, but I see immense value in both. And actually, it's only, I mean, one of the things that's really highlighted the value recently to me is working alongside Gen F, and they've actually recently hired someone who did their PhD in magnetic fusion, and they've become a key scientist in explaining the importance of first wall science and the material science that goes into that. And it's really I mean, in terms of materials, we're really benefiting from your knowledge, from your experience in this field already. But I think it's a two-way communication, and I think there's loads of intercommunication that can really benefit. And a conference like this, where we have plenary talks on both topics, it's you begin to see some of the synergies, some of the points where we have the same kind of problems, and somewhere we don't. And even when we don't, it's I mean, it's kind of like fundamental science. You really build out your knowledge as a scientist, and yeah, perhaps later it comes back and you can apply it in a new and novel way. But thank you. Does that somewhat answer the question?
Yeah, I also heard that you are kind of happy with the program, being in the program committee. Thank you. Anyhow, sorry. Yeah, that has answered my question indeed. So communication, apparently you consider that as an important tool or skill. Andreas, you are like a successful researcher, I said that already. And you said that mobility, you consider that this is important for young researchers if you would want to hire them. Looking back at your own career, what helped you to achieve the position, your deputy director, which you already have? What were the important skills along your career way?
Yeah, I mean, then I was the undergraduate. I was passing my institute, which I've been working now for 16 years. Every 4 years, just passing by, and didn't even imagine that one day I will be working here. But then there was one lecturer who offered the possibility, I mean, to do some, to go to choose the a researcher path. So I've tried to work in, I've started during my master. Sorry. I've started during my master, first year master, and I'm still partly a researcher, and probably the activity helped me to be noticed by administration of the institute. I mean, activity in terms of being active in research, doing your PhD, during the master studies, and then step by step, this activity probably helped me to be offered the position as a deputy director. So probably there's also some portion of luck, but nevertheless, who knows? So yeah, it's this like.
Yeah, but I also heard that consistency is important. This is one thing, I guess. Yeah, yeah. Thank you. Talking about consistency, Hervé, you switched topics recently, as you said, but before that, you also worked on a field where you had to have like a long-term vision. So, in your experience, working on such a long-term endeavor like fusion, which is like 30 years away. Sorry, I haven't said that. How can you stay motivated when timelines are really stretching?
Yeah, that's a good question, and I won't comment on the timeline. I'm not gonna quote any timeline. Yeah, one thing that struck me when I entered the field of fusion, and by the way, I'm the living example that you can actually embrace fusion at any age after the age of 50. So it's really not just for young people. Thank you. Is when I started my career, and a large fraction of my career was more in the laser sources or light sources in general for semiconductor industry, and one of the projects that I saw really right at the start was extreme UV light source, which are today, as far as I know, the only laser-produced plasma device that actually works 24/7, producing the most advanced chips. And I can tell that 30, 35 years ago, no one would think that this thing would ever make it into an actual industrial product. And it took a lot of science, engineering, cross-fertilization between very different world to make it happen, but it did, with, of course, a lot of money, a lot of collaboration, public-private, a lot of human resources, but it did. So if I look at fusion today, yes, the challenges are big. And by the way, as Duncan mentioned, between the MCF and ICF, we share a lot of those challenges. We have very different ways of generating our energy, but we have a large fraction of our problems lie into how to harness it and convert it to electricity. So we should definitely communicate a lot more. But yeah, so I think those challenges taken one by one, they can be solved with the right amount of innovation, funding, and human resource. So there are other examples of very long-term challenging science and technology development that succeeded to make it to the market.
Yeah, true. So I think like taking challenge one by one, but having always the final kind of the goal, picturing it, that probably is the right way to go then, right? Yeah. Yeah, thank you for that. Antonio, you started the field. When did you start your PhD? Was it 20 or 2021? 20, right? Your PhD.
When I started?
Yeah, your PhD.
19.
19, okay. So the fusion landscape has changed this then quite a bit. So if somebody enters the field today, what advice would you give them to stay in the field? What would be helpful?
I think my answer today is the same I would give 5 years ago, even. So I don't think that the fact that the landscape has changed a lot would change much my answer, which would be, so first of all, to try to be the best at what he's doing in his PhD. So to know why are you actually solving these problems? So why are you actually using these equations? Maybe this might be stupid, but sometimes you have someone that is already being 2-3 years into the PhD and doesn't really know exactly why is this term here. My supervisor told me to put it. So try to avoid this, but then not only try to know the specifics, but also please don't forget the major picture. So, and the major picture obliges you to know what are your colleagues doing? What is the guy next to your desk doing? So, at least from a general point of view, to try to understand every section of fusion. This will make your lunches at the lab more fun, because you won't be lost maybe in some conversations. It will make your life easier during a week of conference where you talk about every possible topic in fusion. And then if we continue going outwards, don't forget why are we actually doing. Because I'm sure that if you ask everyone here in this audience, why do we want fusion, why we want to make fusion, 98% will tell you this cannot go beyond because renewables, they won't be sufficient, they are intermittent, their output is not enough. Okay, it's a good start, but I think you should know how to go a bit beyond that. I think you should, especially now that renewables have been doing really amazing stuff during these last years, I think you should be a bit able to go a bit beyond and to say, no, we are doing fusion because we need to put a power plant here and there strategically to lower the cost of electricity, etc., etc., etc. So I think this would be my advice to.
Yeah, thank you. Good advice, I guess. Yeah. One question, Felicity, since you're about to finish your PhD, hopefully, again, no pressure, but you have already some elaborated views expressed here. So do you feel empowered to stay in the field for a long term, to shape it into a certain direction?
Yes. Good. Oh, does this work? Yes. Yeah, so I think this is quite interesting, particularly when you're an early career researcher, because you're at I'm very lucky because I will be going from my PhD into a fellowship. So in that sense, we'll have quite a lot of, freedom to do what I want. But, a lot of the time, if you're early career, you're basically quite dependent on the opportunities that are available to you. So which postdocs you have available to you. So yes, in many ways, I think, you know, you have to be able to, if you want to do something, go and pursue it. And I think that there's lots of ways that you can do that, even as like a young person coming into the field, because you can go up to people and talk. I mean, I asked my supervisor the other day what his 5-year plan was, because I was just interested. And, you know, like you can have these discussions with people, but you are also sort of because I do find it interesting that we kind of often ask people who are quite young, like, what's your 5-year plan? When, I'll be honest, I mean, I sorted out my next 2 years and I was like, great, that's me sorted. I'm not going to think about that for a few more months now until I've got a bit further, you know, because you kind of have to go one step at a time. So I do think it would be really interesting if this is the kind of question that we ask, you know, some of the people who actually have, you know, are able to shape it a bit more as to, you know, how do you think it should be, where we should be moving, you know, the people who are heads of labs or heads of groups and that kind of thing. So yes, and also at the liberty of
Yeah, thank you for sharing that with us. Yeah, talking about leadership, Duncan, you finished your PhD like 4 years ago, so you're kind of not in super early career postdoc, kind of early midterm career postdoc. So you have maybe on the leadership perspective, you have two perspectives in the leadership, being like the one who is kind of led and the one who is leading now, starting to. So how can leadership, in your experience, ensure that early career researchers are kind of heard and that their voice is kind of heard?
Yeah, it's a good question. I hope I'm a late stage postdoc, and you know, but yeah. So the leadership is a very good question, and I think I'm going to refer a bit to what Felicity was saying as well. I've recently gone through the practice of applying for several permanent positions, and one of them is at the CNRS, a French funding body. And when you submit your application there, you have to plan ahead what research projects you're going to do in the future. So you plan 5, even 10 years ahead. This is an immensely difficult, somewhat impossible challenge, but it's very rewarding and very interesting. I mean, you have to take a lot of time and you have to have a good supervisor who's willing to support you through the process, because it can't come overnight. But only through having a plan, only through trying to see the lay of the whole field, trying to evaluate everything that's going on, everything from your understanding in the broader picture as well, do I feel that you can actually then begin to take the leadership role. And so a fallout from me planning my project is I've been able to also assist lots of new master's students and PhD students who I've begun co-supervising. And that's really fed into the leadership role as well. But I don't think I would feel I had the capacity to do that without taking some time and properly planning how my skill set fits in with the larger community, what I have to offer them, and what I can also take from them, what resources I can take from my collaboration, from my immediate groups. And yeah, it's a very useful practice, I recommend.
Yeah, good point. It's challenging but rewarding, as you said, I guess. Yeah, I like that. Marjana, you started to talk a bit about politics as well. So how would you describe, or how can decision processes on a political level being, let's say, guided into the right direction, let's say, from a researcher's perspective, how to represent your interest best when you talk to politicians?
Okay, it's not an easy task. Let's see, we prepared a lot. We have established like several working groups, like government does with politicians. So among scientists, we also formed several groups to work on that, how to prepare agenda, the path, what needs to be done. We tried to count money, we tried to count people, strategies, everything what needs to be involved in the strategy. And afterwards, we every week to each ministry went, and a lot of discussions. We totally were. We haven't heard about quantum before. See, it was really tough, but now I see how fruitful it is. So it means a lot when people start to talk, and every time we learned that it wasn't like we have prepared, and it's not big deal to talk with politicians. Yeah, but every time, first time we failed. See, no one understand that. But later, yeah, now they even want to prepare workshops for them to learn about this stuff, about how looks this quantum chip, or what is the difference between Josephson junctions, yeah, and quantum photonics and so on. We want, yeah. I think in this Kruger curve, they are now in the best place. Like they feel that they understand some things. And Duncan mentioned synergy. I want to go there. That also it proves that okay, we have our strong sectors like life sciences and lasers, and all of them can be powered more by plasma, by quantum, and so on. The synergies, we always need to tell about that. For example, we have nice alumna, Julia Krupic from physics faculty. She went straight to neuroscience, where examining mouses, how they memorize the path, yes, in order to fight Alzheimer's disease. And they knew nothing how to collect the data to see the results and patterns, and she just applied Fourier transform, and they called it brain crystals, and it was wow, Nature journal, straightforward. And now I see that, for example, this Saturday we are going to have this satellite meeting, quantum computing in plasma, for plasma physics, and it's also a big deal because quantum community will come, plasma community will come. Now we are going to communicate and talk a lot, yes. And yesterday I received a letter from Laser Association, our strong field, yes. People are interested in their opportunities in plasma and quantum. So now everything converges into one point. So communication, once again, let's talk.
Okay, thank you. Yeah, again, communication and then just doing it. You're learning anyway. It's all a learning process, I guess. Yeah. Hervé, when you are looking for new young talents in your team, what kind of skills are important? What do you expect from young people joining the team?
Well, probably the key thing from young and not so young is curiosity. I typically will have one of the key criteria for selecting a candidate would be well, the quality of the question he or she's asking. Did he or did she? What is he or what is he curious about? What he is inquiring about? Well, regardless of the job, you should have plenty of questions about the nature of the job, the science, the technology, the company, and it really speaks for how the person will really track the problem, will really try to look at other areas to find a solution, will communicate to others to go and find the solution somewhere else. So it's really for me the key criteria. Of course, we're looking for educated people, good skill set, but curiosity is really the key one.
Okay, thank you for that. You all heard that. Asking questions, being curious is important to get a job. And so I
just a side point, in a job interview nowadays with young people, I'm the one passing the interview. So you should ask me question about, what is the job about? Is the company serious about that? What is the technology about? It's a two-way discussion.
Yeah, thank you.
Selecting me as
much
as I'm selecting you.
Okay, so we are reaching about the hour. I will now slowly go over to the laptop and have a look if there are any questions already. You can already think of some questions, raise your hand. We also have the analog way if you have not submitted something via the Mentimeter, but I will now go over slowly, then you can think about a question. So, questions are here. If you scan and type in your questions, so let's see. full screen. Okay, so I see we have like 13 questions, if I see that correct. So let me read that question aloud in case you cannot read it from the back. So given that postdoctoral pay is relatively low in many institutions, how do you think pay influences the retention of early career researchers? Is this simply a matter of increasing funding? Interesting question. I guess, is anybody willing to directly answer it? Otherwise, I would address the more senior people of you hiring postdoctoral researchers. So I'm not sure, Andrius, is that a question which I can first direct you maybe if you are like, how do you tackle that like to compete with like with industry if you want to hire a postdoc?
Probably it's hard to compete with the industry in general terms. Yeah, but I mean, if the money matters, that's the only one reason for the postdoc. Of course, he will choose the industry or to have higher money. We are also trying to, let's say, to find some internal funds when it's possible. Let's say for some reimbursement, like accommodation, to have some extra on top of the salary, as well as, let's say, to have the opportunity to bring the family. Of course, it's costly and you cannot take every postdoc you want to, but nevertheless, these options, let's say, I saw in Germany personally, from my personal experience at Technical University of Munich, they want to attract the early stage researchers or let's say to work for the project. So they do provide such funds like accommodation. This really helps to let's say to choose this academia instead of let's say industry. So that.
Yeah, understood. Yes, some true points. Looking maybe to Antonio, since you are like one of these postdocs working for industry now, do you have like from the Fusion perspective, being working at a startup, an answer to that?
Yeah, I think Andrews had a very good point. Sometimes it's not just about the paying; it's again about the stability. So if you can, first of all, you need to. So the question to is this simply a matter of increasing funding? No, because if you tell the person, okay, you won't have an amazing salary, but you can guarantee that you'll stay here, that you'll have a permanent position, that you can work for us for 10, 20, 30 years. Probably the person will be willing to accept the offer, even if the paying is not as good as if he would go to industry somewhere else. Mobility. So we have been talking also about stability and mobility, and for somehow I think that mobility is probably one of the biggest fallacies of the research mentality these days, because since I've entered into bachelor, master, then PhD, I've always heard that this is very beneficial for research institutes. You have to move away. At some point, I was told that, oh, if you want a permanent position in Europe, you have to go to the US. You have to spend God knows how many years there. But is it really so? Of course there are some benefits in it, but let's go back to the 50s when you had Lyman Spitzer at Princeton. All the amazing work that these people did there without communicating with anyone there. They constructed the first series of stellarators. Igor Taman, Sakharov back in the USSR, they did all the first series of tokamaks without communicating with each other. So there was a lot of progress in fusion without expats moving around the world. So if of course that then when doors were opened and these people started to communicate, of course that things improved even more. But I mean, we already have conferences. We can already talk with each other. So I still need to be proved that it's still yet to be proven, at least to me, that this fixation with mobility and people have to go and go to UK, Bordeaux, Paris. I still need to they still need to show me that indeed this is the ultimate way to reach excellence.
Okay, thank you very much. By the way, if you have a question, you can just stand up, approach one of the microphones. I will eye them both, and then just raise. So I saw somebody raising a hand over there. Just, yeah.
Do you mind if I just really want to second.
Okay, let's quickly wait for Felicity's comment on that. Yeah, please.
Huh?
You wanted to comment on that, please, Felicity?
Yeah. This does, yeah. I just really wanted to second everything that's just been said, because I think that's that's basically been exactly my experience as well, where as I've been going through my PhD, you get a lot of noise coming at you, which is basically sort of saying, like, after you finish your PhD, you have to move, and if you want to have a successful career in fusion, you have to move to like several different labs. And I totally understand why. I totally understand why moving to different places gives you different experiences, and this enriches your way of thinking and all of this, and and for the institutions themselves, getting people coming in. But also, that's not what everybody wants to do, and it's not also, so some people can't because they have caring responsibilities, they can't leave their family. Also, some people don't want to. I'm quite a homebody. I quite like being at home. I didn't really want to move, and because fusion's such an international thing, usually if you move institution, that means moving country or continent, which is a huge ask. I mean, because when people say, do you want to stay in fusion, like, I really want to stay in fusion, but luckily for me, the question was, do you want to stay where you are and stay in fusion? If the question had been, do you want to stay in fusion, or but you have to leave your family, leave your partner, leave your friends, leave your lifestyle, and go and move to a different country where they might not speak your language, it becomes a huge ask. And that's kind of, sometimes it feels like people are saying, oh, you have to be, fusion has to be the #1 priority in your life. But then you're sort of, and look, I really like fusion. It's not that I'm saying, but then, by doing that, we're automatically kind of disregarding an entire kind of proportion of the population that don't want to or can't make that jump. So, but I also understand there's not infinite numbers of jobs everywhere. So yeah, it's a very difficult balance, but yeah.
Yeah, thank you for that perspective, Felicity. Indeed, Felicity, mobility, controversial issue, yes, and we got now 3 different perspectives kind of on that question. I appreciate that. And as I said, people can raise their hands. Is it still a question over there? Yeah, please, if you just step to the microphone and then you can ask that.
Thank you for being here. So a question that arises within this topic would be eligibility. Certain research facility limit or restricts access to individuals that come from nations that aren't contributing into that project. And to my current understanding, for example, ITER requires a certain level of security clearance, which effectively limits the ambition even of many young aspiring researchers to even enter the field, since they can't work in it if they come from different nations. So do you think future fusion power plant will have the same restrictions, and what can be done about it?
Yeah, interesting question. Thank you. Just to indeed, I do remember one time we had a master's student from Iraq, and we wanted to do some computations. Not possible because being from Iraq, he cannot access the supercomputer clusters. So maybe, I'm not. Is that a question which you can tackle for people from like countries? Are there like, how do you tackle these kind of problems?
Yeah, no, that's a very good question, and actually it's linked to also the question on the screen about how the geopolitical challenges will affect research and funding in the future, because those two are related. Yeah, there are constraints, and they're not all easy to lift. I mean, of course, in our field of ICF, I would say it's very very clear, because as you probably know, the core of ICF research until recently, and still is, defense oriented. So there are constraints, and I mean, we have to be realistic that this field is not going to get open, and I sure hope that open research will stay as open as possible. And it's true that what happens in the world can be really can make us worry a little bit about science being less open than it used to be. So I think it's our responsibility is to try to fight that, and hopefully not to see, because even though I fully agree about we should adapt to everyone's preference, if we are looking at fusion or in general, the amount of workforce is going to be so huge if we want to go all the way to power plant that we're going to need researchers and engineers from pretty much the whole world, and we're going to have to find ways of making it happen within some obvious constraints. And of course, I'm not the one who can solve the geopolitical situation, but we all can.
Yeah. Yes. Thank you for your view.
We all can vote, let's say.
Yeah, well said. Yeah. Duncan, do you working in an ICF, do you recognize some of these problems being like partially maybe military research that some people that are just, cannot join your team and that's it?
Yeah, it's very relevant to my position. The lab that I work at, there is many restrictions put upon me, partly because of my nationality as well. So being an English researcher in a French national lab. I think, as Hervé pointed out, the key is to be as open as possible. And in our field, I think we're still at the very dawn of this. I think for the first time we see it as becoming commercially viable. And I think that commercial viability is opening up a lot of doors that probably should have been open before, but no one cared. And so, yeah, now we're really questioning a lot of the blocks that we put on certain codes, certain people, certain restrictions, and all of that has come into question. I can't give it easy answers. I know I think the US is moving fairly quick to try and open up a load of code so they can be used by nationally developed codes, national lab developed codes, so they can be used by private industry. And I've heard movement in France as well. We're trying to do the same thing, but yeah, it's an ongoing challenge, and I completely agree. It's a challenge that we need to overcome. We need to be as open as possible.
Yeah, probably true. Just a reminder, so in Fusion, we have kind of this international collaboration is something deeply inherited into our roots, if you want. Just a reminder, 1958 declassification of fusion research, when Cold War was start to peak. Then the English delegation, which was sent to Soviet Union in 1969 to confirm the measurements of the T3 tokamaks. So we have some very good history in fusion about international and open collaboration, and indeed, it's a very good question. So we should think about that and trying to make use of any kind of political influence, which we have, kind of what Marjan said. Just try to do it. Maybe we need to work more on that. So it's true. Yeah. There's a reason probably why this panel consists of white European men, so to say. White European people there, and so not many other people there from other countries. So maybe there's a reason for that, and we should work on that better. Yeah. Okay, so I see this question here, how you personally balance the challenge of going abroad and the need to be flexible to continue in the field. Is this family compatible? We had that discussed quite a lot. I'm wondering if whoever raised that question, are you happy with the answers you got so far? That accepting that indeed this is a challenge on a personal level, there's no easy answer to that. And okay, so I see at least one thumbs up. So one thumb up, I go to the next question. Let's see. So, how can we train a huge plasma-lifted workforce to, beyond scientific research, design and operate the next generation of fusion machines? Now, that is also an interesting question. Anybody? Yeah, Evie, I see a hand raised there.
So I have a simple and simplistic answer, which of course is too simplistic. But first step, if we want to do that, is there's kind of a general rule of system engineering is to be able to do a system design with clear interface, so that you don't need to be a plasma literate person to develop a fusion reactor. Of course, you'll need plasma scientists all the way, but you cannot rely on have enough of plasma scientists for the full design. You have to be able to, and that's not easy. Plasma scientists have to be able to set boundaries and specify to other people who will bring their own skills, whether it's mechanical engineering or all material science, chemistry, so that they can take the ball and run with it for their own domain. So that's a really true challenge when going from scientific research to industries, to really build this system engineering approach where you can really expand the workforce available, because you're going to be able to take people from different disciplines and have them contribute really hard. You know, the plasma scientist cannot be the one who's going to develop the diagnostics, develop the material, he's going to set kind of the plasma boundaries and ask others to help him or her. Of course, it's simplistic.
Yeah, well, thank you. Once again, if anybody has a question from the audience, feel free to either raise your hand or step up to the microphone. We happily take these questions as well. Just glancing around the room, doesn't seem to be the case. We are approaching the end of the event. I will take one or two more questions. So let's have a look at the next one. Should we consider our scientific efforts detached from the social and political consequences? In turn, should we put effort into training researchers in science communication? I think I immediately see a hand raised there. So Duncan, please.
Yeah, one of the interesting things I saw in the questionnaire at the start was the few votes for, I can't remember what, the social side of fusion being one of the biggest challenges. And I mean, obviously we just had to pick one, and maybe it's not the clearest one, but we already have a version of nuclear energy that is very, very effective. And there are definitely some downsides and some drawbacks to nuclear fission, but it's the social and political sides that sometimes restrain that technology. Some of them are completely valid, but some perhaps go too far. And we have to be conscious that we may run into this same hurdle. Like maybe all of our dreams come true. Maybe our version of fusion energy is we realize it, it's economically viable. But if we don't pitch it in the right manner, if we don't think about the broader social context, if we don't frame it in the right manner, then we might come into the exact same issues the fission community has come into, the current nuclear technology that could provide us energy. That's just, yeah.
Thank you for that, Duncan. So honest communication is important. Also, this question also brings me to what Marjana said. Communication is important in general. Talk to people, communicate what you are doing, talk to your friends, your neighbors, whatever. This plays a role. Once again, if anybody has a question, since we are soon approaching the end, otherwise I will just go to the next question, taking this as the last one to the panel. That's an interesting one, I love that. What is the limit to the number of postdocs a researcher can do before the employers are no longer interested in them? That's an interesting question, yeah. Is anybody directly willing to answer? I can share perspective. I mean, I did.
I was going to say, Alf, maybe you answer this one.
Yes, so as a background to myself, I finished my PhD in 2010. I still work at a university. It's now 2025, if I'm not mistaken. So that's been quite some time. I'm not a professor. I guess technically speaking, I'm a postdoc. I mean, yes, I like to call myself in CVs principal investigator. That sounds more fancy than being a postdoc. But and yes, I do supervise PhD students because my professor lets me allowed to do this. But he then is taking the care of the academic supervision. And yeah, so technically speaking, I am still a postdoc. For some reason, my employers are still interested in me. And I enjoy being in the field. I hope I can stay a bit longer, maybe sometimes with a permanent position. And yeah, so that all depends a bit on the personal story, I guess. Yes, it is challenging to have limited contracts. That's the reason why I considered leaving the field a few times, but it's just too much fun to work in it. At least for me. So anybody else has a view on that they want to share? How many postdocs before employers are not interested? Maybe you have a comment on that?
Maybe just a comment or maybe some path for improvement. It's true that in academia you basically have the choice between extremely short-term tenure, so typically 2 to 3 years, and lifetime employment. So maybe we have to find middle ground that will be a little bit more balanced and attractive. But that's kind of a
yeah. So I should
very
maybe
candid.
yeah. I think an important point which you said, and I should maybe add to that. I was lucky enough that I always got at least 2 years contracts. I know a friend who did a PhD who had 3 months contracts, 1 month contract, 3 months contract. That was challenging, and after his PhD, he was really fed up with the whole system. It was not in plasma physics, but yeah, this can happen as well. And he said afterwards, academia is done for me, never again. Okay, so that's it with the question and answer session. If there is any other question, please raise your hand. Of course, yes, I see, Ken, you have a question over there. There's a microphone coming from your left.
So if I could be a bit provocative, suppose fusion becomes redundant or uneconomic because advances in renewables, battery storage, and so on. I mean, it's still doable theoretically, but it becomes pointless because of the fact that there are competitors which are easier and less challenging. How would you feel as fusion scientists if that were to happen?
Yes, somebody wants to step forward. Antonio, I see you, yeah?
I think it's not a that far scenario that if we don't act now, if we don't start really designing and eventually starting to construct our fusion power plants, I think it will become redundant. Look at this summer I've been thinking a lot in the example of France, where in some days during the past month, the solar production and the amount of electricity coming from solar that was put on the grid was 70% of the nuclear. And we're talking about France, which is like the bastion of the nuclear, at least in Europe. So I don't think it's a that far scenario. If that becomes the case, I always remember a teacher I had in my master, low temperature plasma, a teacher that would tell me, even if this does not work, it's okay, because we have already found such brilliant and amazing fusion theory, like neoclassical confinement. It's amazing theory, it's amazing equations, it's an amazing thing. So even if it does not work out, I think we should feel very proud about what we have accomplished, and because in the end it all boils down to the fact that it's science, right?
Yeah, I think I sounded quite pessimistic in my opening thing of today, which I totally didn't mean to, by the way. But I think that kind of shows that, because, you know, it is a huge challenge, right? Like doing fusion. There's so many things that have to work together, but at the same time, it's really worth it to try it, because, you know, if we can get it to work and if we can really make it happen, then, you know, the results of that will be really massive, right? So I think that's exactly as you say. I think, like, if one day it turns out, oh no, it's not going to work for whatever reason, probably be pretty devastated at first. But then, you know, even knowing that in mind, you know, the thing that gets you, I think, through when you're going like, oh, is this really going to work, is the kind of hope that it could, if you see what I mean. Kind of doesn't, in some senses, matter if it ends up happening, because the point is that we've tried, and we've tried our hardest, if you see what I mean. So I think that's probably the main thing, I guess.
Okay, thank you. Before we going to conclude the end, I see no further questions. So I have a very last bit of a provocative question as well. Very short answer, only one sentence at maximum. Whoever wants to step forward, you can all answer it. If there's one thing in your research community in particular, which you could change, what would it be? Anybody of you, feel free, Felicity?
I'll state the obvious. I would like there to be more women here, but or just generally more diverse in every way.
I like that, yeah. Anybody else has one thing they wanted to change in their research community?
I have to pick the same answer as Felicity, because, well, not only it's not fair, but we're also, quote unquote, for the engineering, wasting 50% of the population, and that cannot be acceptable. And yes, a better gender parity is really paramount for our community, but all scientific and engineering community in general.
Yeah, thank you for that, Evie. Yeah,
and not just gender, but obviously international, interracial. Like we're
indeed. Yeah, and let's not forget about disabilities, and so
Yeah.
in general, inclusion, equity, diversity. Yes, fully agree on that. Yeah,
one of the big changes.
Yeah, agree. Kind of diversity is key to success, if I might say that.
So one thing I could change, if I could change something in the community, or I mean, stop evaluating people through their age index and number of publications and irrelevant papers that we have been publishing in irrelevant journals through their
Yeah,
career.
good point. It kind of, again, sorry, Marjana, again, for what you said, kind of communication is important. So this should be valued somehow if you give like public talks or whatever, which is not generally valued in this type of number if you want to get a permanent job or whatever. So yeah. Marjana, you wanted to say something, Marjana? Sorry.
Yes, I keep in mind several questions, like in the movie Back to the Future. So why people should come back and stay, for example, in fusion or in academia, that it was proven scientifically that there are 3 factors like people, money, and career or stability. And now there is no place in the world which can give you all 3 of them. But if you have only money and it's a huge, like thousands of euros, it won't keep people in one place because you always need at least 2 factors. So for me, it's people, why I am staying here and working. It's like you never meet so many beautiful minds, like progressive, opened up, or drinking a lot of coffee in order to write some equations and so on. Yeah, it's so fun for me. And this career path, it's not like doing the same thing over and over. You end up one and you begin a new journey. And when I met Anton Zellinger, and also in quantum computing, where people don't know which path will be the only path for quantum computing, and I asked, in which you believe? Marjana, it's gambling. No one knows, but it's so fun. Yes, so science should be fun. Science, no, why we are doing? Because we are curiosity driven, like Harvey said. Yes, we want it to explore more, to learn. It's humanity, and stability is sometimes overestimated. We feel comfortable in our minima, but the beautiful path begins when the phase transition happens to another global minima, and so on you go and discover. Yeah, so be open. Things should change, we should adapt, and it's the only way to progress.
Thank you. Is any other, if there are no further comments, then Andrus, you want to say something?
Just to sum up, and I couldn't agree more with Antonio. It's based on the metrics of H factor, but usually industry doesn't need your papers. They need innovations, technologies, the groundbreaking innovations. So that's, since I'm experimental guy with the applied field, so I feel more comfortable applying instead of more fundamental research. So that's, thanks.
Thank you for that. So we are almost at the end. If I may quickly, super quickly summarize in a few words, curiosity is important, consistency is important, taking challenges one by one, never forget the big image kind of what you said is important. Role models play an important role. What else? Diversity is important. We said that as well. Thank you for raising that statement. Talking is important. So communication is important. Even if you fail, Marjana said that, just doing it in the first place. You learn along the way. Yeah? Okay, so this brings me to the very last thing. So I have another final question. So I will annoy you with another Mentimeter. Sorry, don't worry. This is the very last one. After that, Crystal will give you a few words of thank you and goodbye. But that's the very last one, as I said. So let's quickly, I'm jumping over now to the other screen. Don't worry, I will show it again in a minute. Oops, not working. Present. Okay, now it's gone. Where is it? There it is. Sorry. Okay, interesting. I see different thing. Okay, maybe we broke it. That's weird. Aha, thank you. So we didn't break it. I don't know, something happened. So this is just what feeling or emotion you have after leaving this conference. I'm a bit thirsty, but that's not really an emotion, I guess. And meanwhile, I already say thank you for your questions. These were quite a lot of questions. Before Crystal is concluding this event, I already like to say, meanwhile, thank you to the panelists. Thank you for coming here. Some of you really came here for this meeting. Oh, I really like that you can type emojis. I didn't use that. Well done. So yeah, let's before Crystal says something, I just quickly want to say thank you to the panelists for your time here. Motivation, I like that. Motivation is a good thing, Crystal, for you to take over, maybe to say some last words if you want to. Yeah, I like motivation. Yeah.
I don't have a lot of emotions to add to this. I think it was important to have this kind of discussions, and it's even more important to continue in a more social environment, I think, to communicate. And now is the time for a drink, thanks to our sponsors, and then we can experience more social skills. We can try to get more information from each other, more exchanges. So thank you very much to the panelists, also to Alf for the moderating role. And thank you for coming and for building this community, I think. Thank you.